Super B Productions now, check this profile, minus 16, unbalanced force. All right, we're gonna do the second law of motion here. And the equation that goes with it, actually there's gonna be 3 equations, let's say. All right, the first and most obvious one that you'll see in every textbook in America is gonna be acceleration equals force, class,
The mass.
force divided by mass. Very good. So if there is an unbalanced force, which means something more than 0, divided by the mass, that's the acceleration. So the unbalanced or net force divided by mass gives you acceleration. Okay. So let's talk about this unbalanced force. We'll talk about the situation, back to the book. Shall we use the same colors? Why not? Okay, we got a table here. We got a book on here. And let's say it's going to accelerate in this direction, right here. That means if it's going to accelerate in that direction, we have to have an unbalanced force. So that means, of course, that the force applied will be bigger than what?
The force of friction.
Force of friction, very good. So in this case, net force is equal to force applied minus the force of friction. Now we won't worry about the signs there. If we did worry about the signs, you'd say plus the force of friction. But the force of friction will be negative, so you're subtracting.
So what's the net force mean?
The net force is the unbalanced force, the force other than 0. If the force applied is equal to the force of friction, what's your net force? 0.
So
And if
let's
there's
say-
no net force, which means more than 0, you won't have acceleration.
So if I push this paper across the desk like 5 newtons and the friction was 3 newtons, then the net force would be 2.
Perfect. And then you divide it by the mass, and you find out how much it accelerated.
Alright.
Now that's side to side. Now if you have a situation where someone jumps out of an airplane, let's say this is maybe Taylor, we just tossed him out the airplane there. And there he is. Spread eagle position. There he is. Immediately, he's going to accelerate.
Regret my decisions.
Unfortunately, he's got a parachute pack on right there, and it'll open pretty soon. So we got his weight, which is very big, okay, compared to the air friction, which is very little. And so he's going to accelerate. So in this case, the net force is equal to
Force
the weight
minus air.
air resistance. There you go. And so whatever what that difference is, you divide it by his mass, and that'll tell you how much he's accelerating. Got it? Got it? Good. All right. Perfect.
You divide by his mass?
Mm-hmm.
Oh.
See if you can airdrop me those while we're